Hi everyone. This video will discuss about the adaptive cruise control using LabVIEW. Actually, in this autonomous connected vehicle lecture series, today we discuss about the second experiment, adaptive cruise control using LabVIEW. Actually, in the previous video, we discussed about the cruise control only. Now we are to use by the adaptive cruise control. The adaptive cruise control is maintain speed plus safe distance. The include the maintain the speed also. Previous cruise control only we are not don't consider about the uh, distance from the vehicle. So this we have to discuss about the adaptive cruise control using LabVIEW. So why we have to use the adaptive cruise control? Normally is the we maintain about the constant speed. As we want to look at about the before the vehicle distance also. So we want to look the based on the vehicle distance. Suppose we want to reduce the speed means the we want to apply the brake and reduce the speed. So we want to maintain about the safe distance. The control mode. So how we have to control maintain about the constant speed and as well as the we check the distance of the before the vehicle. So lab use here we have to use by some basic logic to understand about how to use by the adaptive cruise control. Normally how we have to use means the extend the cruise adaptive cruise control, extend cruise control with the front wheel sensing, used by the front wheel sensing to measure the distance from the your wheel and front wheel. So find the distance, uh, find the distance according to we have to control. It use the distance or time headway decide to whether to maintain or reduce the speed based on the distance. So we maintain the whether we have to maintain the same speed or reduce the speed. This basic UG model can be implemented using the threshold logic and a case structure. More advanced cruise control using the radar, relative speed, time gap, and braking dynamic. Here we have to use in the LabVIEW model. Just we have to use a simple logic to understand about the how it is working. Adaptive cruise control. Normally, the safe distance is the time gap multiplied with the vehicle speed. If distance greater than safe distance means we maintain about this desired speed. So you assume for the 5 meter distance means above the 5 meter, like 6 or 10 meters means we maintain about the cruise control the desired speed. If distance is the less than safe distance, it is a distance is the 4 meter or 3 meters means we want to apply the brake and reduce the speed. That is the second condition. Two condition, if condition whether it is a greater than the desired, sorry, greater than safe distance or less than safe distance. Then we apply the brake. We have less than safe distance. The basic architecture. We have to look at about the we measure the desired speed based on that wheel sensor to we measure the desired speed. So we use by the radar or distance. We are to use by the sensor to identify the distance, or we use the radar sensor or vehicle sensor to identify the distance. Compare the gap, whether how much gap between the rear wheel and front wheel. So mode selected, we have to apply the brake or cruise. We have to maintain about the normal cruise speed. Now we have to use by the speed control and the brake state, whether you have to apply the brake or not. This is a basic structure about the adaptive cruise control. So free driving and following threshold selection should be simple and explained in the UG lab. So we want to explain in the basic understanding, the basic logic we have to use to how to implement in that adaptive cruise control. Safe distance can be fixed or speed dependent. Here use the different lab view panel. So this is your front panel and here is the front panel and the control. We have to compare with the decide speed, distance, front wheel, safe distance, reduce the gain, key value, stop button. So those things we have to use. Here's the front wheel, the vehicle speed, brake indicator, stated display, and speed versus time chart. So those we have to indicate it in the front wheel. Normally in the graph, you have to maintain about the record the speed. That purpose one we use this graph. Yeah, already we discussed it based on the architecture. So if distance is the less than or equal to safe distance, we have to maintain about the. So we look at about the speed, whether we have to maintain the speed or reduce the speed. That is, we have to look at about in this lab view block diagram to implement it. Actually, there is a different step-by-step procedure. Anyway, we discuss about the LabVIEW block diagram. Here we are to do in the step-by-step procedure. Now, first we have to create the while loop and the case structure, whether yes condition and false, true condition and false condition. True condition is the we taken the based on the logic. We want to taken about the we apply the brake means we have to consider the true condition. So we are not apply the brake and maintain the same speed means it is a false condition. We take another true or false condition to we apply the brake or the display the safe braking. We have to use the indicator to display the concept of this gas to the waveform chart. So run the VA to very distant slider. So we observe the transition from the safe to braking condition. This is the various steps to follow. Here we have to use the different parameter. And now we taken about the different safe distance, 10 to 15 meter. You consider for the 50 meters is the safe distance, minimum following distance. You have to maintain about the 10 to 50, above the 10. 10-meter means it is the safe distance. The desired speed, you want to consider for the cruise control, you want to maintain about desired speed. We fix the desired speed, 0 to 120 kilometer per hour. Reduce the gain value. So gain we have to put the 0.321. Critical distance we taken about the 5 to 15 meter. Suppose your distance is a 5 meter or less than 5 meter, we have to apply the brake desired level. So here we have to run the clock. Here we have to use by the 10 millisecond. So tuning guidelines. Begin fix the safe distance for simplicity. We have to maintain about the safe distance and we check the whether we have to apply the brake or not. If the speed depends on the safe distances and extension. Keep the gain small enough to avoid the sudden speed drop. So clearly separate warning to the warning and the braking test. These all are in the expected output. Now we have to maintain about the distance of 60 meter means that is a safely we have to run the vehicle. So we distance the less than 10-meter means we want to apply the brake and indicator the brake valve. The increase in the desired speed. Now we have to the distance is a very acceptable level means we can increase the desired speed also. So adaptive cruise control, compare with the cruise control is the we want to include the distance also. Safely we want to run the vehicle. Okay, in autonomous vehicle we want to use the sensor to we have to maintain about the how much distance in the front wheel. So that is based on the distance we can apply in the adaptive cruise control. Normally in the nowadays in the vehicle is available for the cruise control. Suppose adaptive cruise control used for the autonomous vehicle used in the adaptive cruise. So these are some basic mistake, and we want to do the troubleshooting. If stated, we have to maintain about the correctly. We have to maintain the if status, and also parallel you want to look at about the case structure, true and false case structure. Updated only after the stop. So we know about the chart updated in the after the stop button. It is a recorded one. So it is not in the onlinely vary the graph. Only the stop button only it is working. Do not use the waveform graph for the live plotting. Use one common output tunnel to the speed, brake, and the status. Check all tunnel and wires in both cases. So these all are in the learning outcome for this cruise control. Different cruise control and adaptive cruise control use distance sensing to switch the control model. Implement the case-based decision logic in LabVIEW. Interpret the speed reduction on the brake indicator. Um, so next learning steps. Next, the student move to the longitudinal distance control, lateral steering control through the landscaping assistant for the next text. So these all are in the observation from this topic. Find the distance at which brake is turned on. Safe distance of 50 meter, 25 meter, or 40 meter. We want to decide that safe distance. Yeah. So based on that regulation, in each country they follow in the different regulation. Based on that regulation, we want to fix the safe distance. Record the vehicle speed output for each condition. So modify the logic, include the warning state. So these all are the basic Viva questions. How the adaptive cruise control different from the cruise control? What is the safe distance? Why is the case structure useful? What is the sensor is commonly used in the adaptive cruise? Okay, this is theory. Next, we discuss about the how it is this adaptive cruise control implement in the LabVIEW plot. We go with the start button. Yeah, create the project blank control. So this is the front panel and the block diagram. Now you want to use first you take in the while and case texture. Right click texture while loop. So I want to take the while loop. Then next the structure case structure I want the case structure. So for true or false condition. Yeah, the for case structure we taken the true or false condition. First we taken about the true condition. Now we want to take about the desired speed. We want to display the desired speed. Use the knob to here is the desired. To get desired speed. So I want to vary from the 0 to 200. 200 kilometer per hour. So I needed for the display the value. So we write down digital display. I can able to get desired speed. So this is the outer side of the case texture. Then we want to compare with the desired speed and desired speed. Now we taken about the distance. Numeric that I put the vertical slide for the distance. I taken about the 10 meter. 10 meters is the safe distance. So vary from this scale, vary from the 0 to 20 meter. Here also I put the digital display. Yeah, distance check it. So distance. I want to compare with the distance. So I put the comparison statement. Uh, Comparison less than or equal. taken about the comparison, the constant. I check in the 10 meter, whether is whether less than or so less than or equal. Less than or equal. So compare the distance. Distance is less than 10 meter means what is the true condition. The condition satisfied means I want to put the one indicator. Boolean, so that break indicator. Break I put this side, outer side the case structure, directly connected to the break. Okay, so connected to the break true condition. So now we want to display the speed also. Right click and gadget. Here is the actual speed. Actual speed. That actual speed I put in the right side. Here I want to reduce the speed. Apply the brake means I want to reduce the speed. Here we got to use the numerical multiplication. So a basic small logic. I just multiply with the 0.5 and then it is the reduce the speed. And here you have to put in that constant 0.5, 50% of the speed. This is the true condition. Now we go with the false condition. False means it is meaning for the greater than 10 meter. Change to the false condition. So false condition, we want to directly connect it to this to here. This is also false condition. Yeah, break directly connected to the break. Yeah, true condition and false condition. Now we want to, this is the for while loop. Right click, create control, the stop button. I want to maintain the speed and the time clock. I put that 100 millisecond. Under millisecond. Also, I want to put the additional graph for the update the speed versus time. This is a brake indicator. This is speed versus time. I want to record the value. So here I want to record with the actual speed. So you change to that indexing. I want to save the data. Actually, in the adaptive cruise control, we taken the desired speed under true and false condition. The true means we are less than 10 means to apply the brake. The same time want to reduce the speed. Reduce the speed. The false condition. So false condition. So no need to reduce the speed because it is a greater than 10 meter means it is a maintain the actual speed. Okay, so here put the stop button. We run the experiment. So the case structure true and false condition. So we have to run the LabVIEW. So now we consider for the desired speed is 100 kilometer per hour. Suppose we want to measure the distance. Distance is the Here, wait, I think change to this one. 10 meter. I want to change the distance to the 10 meter. So it is maintain about this, the less than 10 meter means I want to indicate the brake. Suppose you greater than 10 meter means the same 100 km speed run in the vehicle. So no need to apply the brake. So you are above the 10 meter, whatever 20 or 30 meter means it's maintained about the 100 km per hour. Suppose it is looked about the less than 10 meter means it is a reduces speed, 50% of speed. Suppose I put the 80 means now you have to change to the 40 km. The throttle position you have to change, otherwise you want to apply the brake to maintain the speed to the 50%. Suddenly we have to apply. So because reduce the speed as well as we have to apply the brake. Okay, that is it is mentioned about the brake indicator. Suppose you put the stop button, then you have to identify for the how much speed. Initially is the 0, then we have to maintain 100 km. Then we apply the brake. If you apply the brake, actually in the apply the brake 50 km, then it is maintained about the 100 km for the safe distance. Now I change to the desired speed is the 80 kilometers. 80 kilometers. Suppose the safe distance is the above means it is a running, but I may it is the safe distance less than 10 meters. So it is the half of the speed of 40 km per hour. So this is your second experiment, adaptive cruise control. Compared with the previous one, this one we have to include the distance, safe distance. Yes, include the distance, whether it is maintained about the less than 10 meter means it is the less than 10 meter means apply the brake and this is for adaptive cruise control. Okay, thank you everyone.